Welcome back to Physics with Miyoshi. Today we're going to talk about kinematics in two dimensions, and we're going to do a little example for kinematics in two dimensions. This is a falling object that's got some x component in its problem. One thing that I was going to mention before, and I thought about it a little bit, but as you're drawing your picture, don't get too detailed. Don't be too much of a doodler. I have a Foxtrot comic strip in my room at school that has a great thing about doodlers not trying to take physics. Anyway, don't be too much of a doodler, but have some fun with that. At any rate, we have here an airplane dropping off a care package rather than a bomb, and it's going at a speed of 115 meters per second. And we drop out a package out of that plane. And that package is going to have zero velocity in the y direction, but it's still going to have this x component in the y direction. Again, if we neglect air resistance, then we should have a nice, neat fall, and we'll find the final velocity and the time, knowing that the height is 1,050 meters. The reason why it's got the negative in there is because we are falling from a height of that. So we're falling from that height. So, how do we do this problem? Well, first of all, we're going to draw a picture, which I've already done. And then, we're going to use this equation right here. But instead of x, of course, we're going to use y. And, so now we're going to look at y. And again, I'm going to use y to find my time. So y is v0 in the y direction times t plus 1/2 a in the y direction, of course, t squared. And so we can solve this knowing that v0 y is going to be 0. We can now say this guy, we can rearrange the equation, and we'll find the t all by itself, or t squared in this case. So I have t squared on the right. I'll multiply by 2 and divide by 2a. So I get 2y over a in the y direction is t squared. So, I'll just move that across over here, and 2y over ay. Now, in this case, ay is just gravity, so we have 2y over g. So, t squared happens to be 2 times y in this case is negative 1050, negative 1050 meters. Gravity is negative 9.8 meters per second squared. And again, the negative for that is because it's going down, acting toward the ground. I could multiply out the negative ones, and I end up getting t squared is, drum roll please, 214.98 meter second squared. There's no meters there. So t squared, get rid of that. The square root, if I take our square root to take care of that. So now I have t is the square root of that guy, which is 14.6 seconds. Okay? That's a wonderful thing to know. Now all I have to do is do a couple equations. If I remember t is 14.6 seconds, now I can use that to find my final velocity in both the x and the y direction. Okay, so let's just keep that time. So I'll keep that there for a moment while I get rid of this guy. So we'll keep that there. 14.6 seconds. Alright, now, how do I find that final velocity? Well, let's make a little vector over here. Vector diagram. And what I'm going to do is, I know that this is my v final in the x direction, and this is my v final in the y direction. And this is what we're trying to find. We know this guy, and we don't know the v final either. And then this will be that guy there with an angle theta. Okay? Well, we know our initial x direction is going to be the same, so that's going to be the same as our v0x, which in this case was 115 meters per second. And then the VFY we can find again from this equation right here. So we will define that guy as v0 in the y direction plus a times t. Well, we know a and we know t. We also know the vy is 0. So this guy is going to be negative g, or negative 9.8 meters per second squared times our 14.6 seconds. So this guy is going to give us, what is that? No, what happened to it? Oh, 143, negative 143.45 meters per second. That's going to be our VFY. Okay? And again, the negative tells me that's going in the down direction. So now, how do I find the angle here? Well, that's, again, if I draw my picture correctly, I know that the tangent of theta is going to be VFY over VFX. Okay, so VFY is negative 143.45 meters per second. Divide that guy by 115 meters per second. Our meters per second divides out there. So our tangent of theta, is the tangent to the negative 1, or arctangent, of minus 143.45 divided by 115. And that theta then will be negative 51.28 degrees. The negative, of course, means that it's coming south of east, if you will, or south of the horizontal. So we could just say that our final velocity, then we could find our final velocity here by doing the Pythagorean theorem. So we could do that. V0 is square root of Vfx squared plus Vy Fy squared, which is going to give us, that guy's over there, square root of Fx, 115 meters per second squared plus negative 143.45 meters per second squared, and that will give us 183.86 meters per second. And if I have too many significant digits there, but I'm not so worried about that at this point in time. But I have velocity, our final velocity, because that shouldn't be V0. That should be VF. VF is 183.6. Well, let's do this here. Our VF vector is 183.86 meters per second at an angle of negative 51.28 degrees. So, again, we used the vertical component here to find our time, and then we used that, knowing that time, we used a couple other equations to find our final velocity in both the x or the y direction, knowing that the x is going to stay the same. We used the Pythagorean theorem to find our magnitude, and then we used the definition of tangent to find our angle, and found it out to be 183.86 meters per second at an angle of negative 51.28 degrees. So, again, you can see that this is one problem that kind of is broken into two problems, and that's how we solve kinematic problems in 2 dimensions. So I will give you another problem or two here in the future. Thanks for tuning in to Physics with Miyoshi.